And we're live. All right, so let's do this for real now. All right, so these are the different ones you're supposed to check. ASA, AAS, and ASS. Otherwise known as ASS. All right.
Like Jack.
So these are the ones just for your health. So these are the ones we want to check to see if these are enough to prove triangles congruent. So what does this mean? This means that the first one means that we have two triangles that share two angles like this. Let me zoom in a little bit for you. Bless you, and enough. All right. And that these sides match. So if we have two triangles that have an angle, a side, and an angle all matching in that order. Again, order matters here. Right? There's a different order here. If they're matching in that order, the question is that enough to prove the triangles are congruent, right? If we know that much information, does that prove the rest of the triangles congruent? So what we're going to do is we're going to experiment with this type of stuff. So first off, I need a segment that they both share. That's the same length. So I'm going to do 4 across for both. And you can see that they are the same length on here. Let me adjust this so this is not crooked. Okay, great. Wonderful. Fantastic. Good job, everyone. All right. Now let's make sure their angles match. So I'm going to put my protractor on the end of this segment, and I'm going to line up this line with the line segment. Give me an angle measure that is acute.
25.
Awesome. Can you give me one that's in a multiple of 10?
60.
60. Nice.
Maybe you should have asked for that in the first
I know.
place.
Did I get upset?
No,
No, I just re-clarified. Yeah, you did.
Yes.
Oh my God.
You need the chill.
Yeah, you do.
Yeah.
All right, so now this is an
Okay.
arbitrary length, so I'm just drawing it infinitely. We'll cut it later because it doesn't need to be a specific length, right? We didn't say anything about that. So here's our 60-degree angle. I'm going to do the same thing over here. Start thinking of another acute angle that I can
40.
do. Oh, wow. Great job.
25.
We're going to do 40 because that's a multiple of 10.
40.
All right. So I'm going to put it on this side now, and so I'm going to look for 40 over here because I'm going this way. There's 40. So I'm going to put my dot. And you'll notice that when I do this, I didn't define how big the sides are going to be, but it did happen automatically, didn't it? So let's do 40 over here, and let's see if we get the same triangle. And it turns out, yeah, we did, right? This is our 40 degree. That's our 60. There's our 40 as well. So we get the exact same triangle. All I did was make sure I had two angles and a side in between them that was matching between them, and the rest of the triangle just kind of naturally happened. So it turns out ASA is enough to prove the triangles are congruent. If you know that they share a side or an angle, a side, and an angle in that order, then they will be congruent. So that one works. Let's try angle, angle, side. This one's going to be a little bit more difficult. Yeah.
Wouldn't it be angle side if you just go the opposite way around?
Nope, because we, yes, it would be, but we have an angle in between that. Great question, great question. So you see how we would have an angle in between?
Yeah.
Yeah. Mm.
Okay, but how do you know where, like, it's in order, obviously, like, how do you know where that order is at? Like, you have, like, the 60, and then, like, how do you know that that angle is your first angle?
So the only angles that I set specifically from the beginning were this angle and this angle. I didn't mess with this at all. That just naturally occurred. So I had angle, side, angle established, and the rest of the triangle just kind of came together.
And like, why don't you start at 40?
Yeah,
I could have done that, angle, side, angle.
like, for angle, side, then it would just be, like, the same thing, but you would fill it in.
So what I would do for angle, angle, side is this. So I'm going to establish a side first, just like I did. Just because it's easier that way for demonstration purposes, especially on that. So we have our matching sides. I'm going to establish two angles. So instead of an angle, side, and an angle, I'm going to establish side, angle, angle. So I'm reading this kind of backwards for demonstration purposes, but it's still the same thing. So I'm going to set up this angle. Let's do 60 like we did last time. Actually, let's do 40 on this side. So there's a 40-degree angle. I'm going to do the same thing over here. Here's 40. And now I'm going to set up another angle. So I'm going to go over here. I'm going to rotate my paper. And I'm going to set up another angle here. Okay. Now, in order to make this a triangle, I have to make sure that that angle does intersect with this line, because remember, this line cannot be extended. It's 4 exactly. Right? That's part of our sides that we're keeping, right? One of our sides that we're keeping. So give me another angle that you want to see. Make it acute, please. 30. All right. So I'm going to go here, and here's 30, and I want to make sure that when I draw that line, it hits this guy perfectly. So I'm going to cheat a little bit and make sure it does. That way we can see the triangle come together. All right. So for that to be 30, it looks like that'll work. And when I draw a 30-degree angle, we get that. So it does kind of make the triangle for me, doesn't it? Same thing over here if I were to do 30. I could, of course, do 30 way out here, but it wouldn't intersect. I want to make sure it actually does make a triangle, right? We are comparing triangles here. So assuming these are triangles, which I think is a fair assumption, and we're given a side, an angle, and another angle, it does look like that will be enough for them to be congruent. Oops, not that one, this one. My bad. Same triangle. So it turns out angle, angle, side also works. Angle, angle, side. Are you with me? Okay, we can also read that backwards. Side, angle, angle, doesn't matter. Forward and backwards are the same. Kind of like we were doing yesterday, right? We didn't count the forward and backward ones. ASA and AAS are not forward and backwards of each other, so they are separate, right? So both of these work. The question is now, does AS work? And we're praying. We are praying that it does, right? Okay, so let's do that. So 2 sides and an angle, in that order, right? Not an angle in between like ASA, but backwards, right? But 2 sides and an angle. We also need to check this one, I suppose. SAS. So let's check AS. So that's 2 sides established early. Let's do this one 4. And then let's do another side. What side length do you want to do? 2. Okay. So in order to do that, actually let's not do 2, but let's do this. It's not really 2. Actually, how long will that be? Does anybody know how long that will be? Well, Pythagorean theorem says 2 squared plus 2 squared, that's 4 plus 4, which is 8, so this is root 8. But they are congruent, yes?
Yeah.
Okay, so we have matching side, matching side, matching side, matching side. So there's our double S. Now we just need A. So what I'm going to do is I'm going to go over here and set an angle. Now remember, when I set that angle, I want to make sure it actually does intersect with this to make a triangle. So I don't really get to pick that angle. The angle's kind of set for me. So whatever this is, it looks like 20 degrees, right? In order to make that intersect. So assuming we are talking about triangles here, not just some weird collection of line segments. If I know that a single angle and 2 sides match, then the triangle itself themselves appear to match, right? So this angle and this angle matches, and the sides match. Now, when we did these last few ones, the triangle kind of naturally appeared, right? Same thing with this one. For this one, I cheated a little bit because I had to have 20 degrees here to make it match, right? I had to have 20. I couldn't do anything else. This one I started with 40, which then led me to have this be 30. But my choice here then gave me my choice here. Same thing for 60 and 40. For this one, I had to do 20 here, otherwise it definitely would not have worked, right? I also chose this angle, basically, when I decided to do this length of root 8 for both of them. Right? I could, in theory, have bent this root 8, and it would have changed it. So pretend I'm taking this length right here and moving it. Right? That would have forced me into a different angle over here, and I could have had a different triangle. So this is the same length. So what I'm trying to say is that this one right here, when I chose 40, it made me have to basically choose 30 here, and that's okay, right? That locked me in. We want to be locked in for it to work. This one over here, when I chose root 8, I arbitrarily also chose this angle, didn't I, right? And when I chose that angle for both of them, it was like I had side, angle, side, which we already know works, right? But if that angle here is different, like I've shown here, right? If that angle is slightly different, because again, it doesn't have to be the same. We're not testing side, angle, side. We're testing angle, side, side. Then I get a different triangle. So it's kind of hard to see. I'm going to walk you through it again. Bo, are you with me? Okay. So when I chose root 8 and 4 for my sides, right? We're testing ASS. So when I chose my two sides, 4 and root 8, not only did I choose root 8 for both of these, but I also kind of chose the angle it was going at. So really I was testing side, angle, side, which we already know works, right? It locked me into a triangle. But if I change this angle, right, and only focus on this angle and this angle here, I've got angle, side, side, which is actually what we're testing. And I can have two different triangles given the same angle and two sides. This angle gets adjusted, right? This one wasn't locked in. So it turns out ASS is actually not enough to get it done, which is a shame because it would be very funny, right? So it turns out whenever you write ass, you're wrong. So that's fun. Same thing with SSA. So the thing that most people see is they see ass and they go, oh yeah, that one's wrong, I can't use that one, they remember. The thing they always forget is that if it's spelled backwards, ass backwards, that's wrong too. Which I think is easy to remember if you think that ass backwards is a popular saying for something being very wrong, right? So neither of these work. Sorry. I know, isn't that sad? I want to live in a world where ass is right. If ass is wrong, I don't want to be right.
Sounds like a personal problem.
Actually, it's not. SAS, let's test that one. Side, angle, side. So, here's the side of 4. Again, I'm just choosing 4 as an arbitrary number. They just have to match. And then we want to test side, angle, side. So we need angle and then another side. So what angle do you want me to make? Make it acute in a multiple of 10. Taylor, go!
30.
Good job, Taylor. Guys, Shelby's on fire right now.
Oh, that's Shelby. I'm Taylor.
What?
Finish your question.
Can I be
That's so stupid.
hot?
What's
Hot.
Remember what I said?
You're
Jericho.
Jericho and Bailey.
Sounds like a personal problem.
Bailey's Jericho and
Oh wait,
Jericho
pot is a
Bailey.
drug.
I was gonna say.
I mean,
About taco.
I feel like everything's a drug
What
if you
about-
like think hard enough.
Pilar. I met a girl this weekend and she introduced herself by saying, "Hi, I'm Mary Jane," like the dress.
That's
Mary
great.
Jane's a drug.
Yeah.
Bailey
Okay.
Jericho.
I think everyone should introduce themselves that way because it makes you wonder, like, hi, I'm Jared, I like the drug.
Can I
And you'd
be?
be like, wait, what? There's a kid,
Pilar.
right? You're like, I am Shelby's kid. All right,
What's
so
my name?
we know side, angle, and then we need to set another side length.
Can I be flat?
So this side is locked in.
Or Uncle Tom's cabin?
No, that is not something you want to be called.
Yeah.
All right, so
Yeah.
no, not a good idea.
What about the Jungle Book?
That's right. Also, highly racist book. Could we pick anything else? Literally anything
The
else.
cat.
What about Mabel Lucy Atwell?
I don't know. That sounds like an
That
author.
sounds like the author.
So
Or
I think that's
Charles-
probably safe.
Charles Dickens.
Yeah, I think we'll go with that. We'll have to find a shorter way to say it though, because that's just too many words. All right, we'll get creative. So we need side, angle, side. We have side. We have angle. We need to establish another side. So I'm going to cut this side to a specific length for both of these. I think what I'll do is I'll stop it right here on both. So that's, what are we doing here? Here? So these side lengths are the same. I don't know how long they are off the top of my head. I guess I could figure it out. It's 4 by 2.5, basically, so we could square both, add them, and find the length, but they are the same. So when I have those sides locked in, is there only now one way to make this triangle? Yeah, it's to connect like this. So it turns out side, angle, side will be enough.
I knew that one.
Cool. So
I didn't.
what we've learned since yesterday is that side, side, side is enough to lock it in, but angle, angle, angle is not, right? I could have lots of triangles with the same angles. Like think of an equilateral triangle. It's 60, 60, 60. Now think of a bigger equilateral triangle. It's 60, 60, 60.
But longer.
Because they have to 180, but bigger, right?
Wow.
Side, angle, side works. Angle, angle, side works. Does side, angle, angle work?
Nope.
Yep, it does. It's just the reverse of this.
Yep.
What about side, side, angle?
No.
No, because that's ass backwards,
Yes.
right? So that does not work. What other ones work?
SSA.
Cool.
Oh wait, no,
I
that's
go home.
Nope, can't. You have to stay here. these two, this one right here, and this one right here are kind of like the reverse of each other, right? Switch S for A and you get the other.
What?
Angle, angle, angle does not work.
My cat.
Angle, side, side does not work.
Or SSA.
Yep, or backwards. You'll need to unlock your iPhone first, Taylor.
That was Courtney. I don't have a microphone.
Yeah,
It's a joke.
What's my name?
Wait, were you talking to me or to
Pot,
her?
I believe, right?
No.
Or
No,
Mary
he's-
Jane.
Call her Flower.
I'm
I
Charles
think I'm good.
Dickens.
Chair sounds like a good one.
Chair?
Yep.
No.
That was.
Her name
Taylor's
is Chair.
name is Flower.
Or Pit for pooped in pool. Yeah, you guys know she went to ISU
No.
last week for theater camp?
No.
They have a huge pool.
No.
Did you?
No. No.
Winter camp.
No?
No.
Right.
No.
I went to
Shut
winter
up.
camp.
Like, commitment to your role.
I hate literally
Actually, I've
everyone
got, like,
who.
pot
Like, when you
belly.
make up a character to, like, act out as for improv, they have to have, like,
I've
a
never done
quirk.
that. This
Do
is
you
not
always, like,
weird.
make that your quirk?
I think
No,
my
we've
name
never
is
done that.
Pot
Okay.
now.
We've
done improv before.
Well, I haven't.
Anyway, those are the ones that work.
Kirko.
So here's what we're gonna do.
Scott.
Oh, there's one last thing.
Because she was born.
Guys, so there's a thing. Okay, so ask works in one case.
Hey, you know what's not funny anymore?
What?
The joke that you keep repeating.
I'm sorry, what joke was that?
I think you know the joke.
I don't know what joke she's talking about, YouTube. Leave a comment if you want to like figure out what it is. Take a guess. All right. So if we know that we have a leg and a hypotenuse matching, they work. This is angle, side, side. It is ASS, and it does work, but it only works in one case when we're talking about the 90-degree angle. Yes.
So, like, I don't know if Jericho already said this, but how would you know it's ASS? Couldn't it be SSA?
Yes. Forward and backwards are the same thing.
Got it.
So ASS and SSA are the same thing, and they work actually in one case.
Wait.
When we're dealing with a 90-degree triangle. So we call it HL for hypotenuse leg, because not only is it just a regular side, it has to be a specific kind of side, the hypotenuse, which is the side opposite the 90-degree angle. So if we know a hypotenuse and a leg match, well then we know the other leg by Pythagorean theorem, right? If we know two of or if we know a leg and the hypotenuse, can't we get the other by Pythag? So it locks it in. So really what we have here is SSS, because we get this one for free, which is why HL also works. So HL is another theorem we have. Yes?
So, like, when you're doing the other ones, how do you know which letter comes first?
Okay, so we can either read it forward or backwards, and they're valid. So SAS is the same thing forward and backwards. AAS, SAA, that works too. Okay? Forward and backwards is fine. AS, both forward and backwards, does not work. Angle, 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 both forward and backwards does not work. Do you understand what I'm saying?
Yes.
The only time ASS works is when it's actually HL. Okay? Last year we called this Cheeks
Actually,
theorem.
SSS.
Cheeks.
Why?
Because it's ASS,
That's me.
HL.
I got it. Wait, I caught on.
This is my name.
No,
Pot.
no.
That makes sense. Alright.
Did you get that video?
Oh, always.
Can you send that to me?
I
Always.
didn't hear you saying this is my name. Pot.
I'll do it again. Skip names. I'll do
Nope.
it again.
We're not
This
skipping
is
you.
my name. Pot.
You're welcome. Where is everyone today? Hopefully they're watching at home.
Do I look like Taylor? Like,
No, you
my
don't.
hair like this?
No, you don't look like Taylor.
Like
I look like
No, Taylor has amazing hair. You have terrible hair.
I do.
Alright. Here you go.
Hey, don't jerk up.
Diana.
Hey, look up in Spanish. Jericho in the pool.
What did he do there?
Look up Bailey's name.
What if we skip that and pretend that
Or what if
no one ever
Taylor's name is Flower?
This is the greatest rumor that has ever happened ever. I hope Miss Palmer has to have like an entire class discussion about rumors of being bad because of me.
I know.
Hobbies are dating.
If Miss Palmer ever has to talk about rumors being bad, all of you need to be like, you need to talk to Mr. Matt. He's the biggest rumor spreader,
No.
because I am.
Why would Miss Palmer
I thought
talk
you
about
were
that?
gonna
Apparently she did one time.
I'm
Were you
really
the one
mad-
that started the
I'm
rumor?
so mad at Jack. You don't understand.
Who's Jack?
I didn't start it, but man, am I keeping it going.
For my hobbies,
like a smooth screen. Right?
For my hobbies, he put dating varsity football player.
You
deserve it. You deserve it.
For each pair of triangles.
Can you throw me something to write with?
Yep, I can. State the postulate or theorem that can be used to conclude that the triangles are congruent. So it turns out that for our purposes, we're going to say that ASA is a postulate.
Can you send me a pen?
Yes.
What was that, Michaela?
This one's side.
She didn't want me to throw it. All right. So we're calling this a postulate. Remember, a postulate is a leap of faith that we're accepting to be true. So we are assuming that ASA is true. That when we know an angle and we know the other angle for a triangle and we know a side, that the two triangles will indeed be the same.
So are all of them
Okay?
postulates?
So that's going to be a postulate. We're actually going to call the rest theorems, and we're going to use this to prove them later. So all of the other ones that we mentioned, like AAS and SAS, etc., those are all going to be considered theorems. But for your purposes, all you need to write is ASA, SAA, whatever, okay? You don't need to write postulate. So looking at number 1, we have 3 triangles for number 1, actually. We have triangle FGI, which is the left-right right triangle, or at least it looks like a right triangle. GIH, and then we have the big triangle GFH. So we want to prove some triangles congruent here. So it looks like to me we have a side that matches for both, and we have an angle that matches for both, right? So we have side angle. If we can find another angle, we can do angle side angle. If we can find another side, we can do side angle side.
I found an angle.
You found an angle? What angle other than the ones that they gave us do we know?
It looks like there's a 90-degree angle.
It does look like it, but can we assume that?
No.
We cannot, so that won't be enough. So we have our 2 angles, and we have our 2 sides. Is there another side that we can find? Because we can't assume the angles, right?
The bottom
What do you mean the bottom?
can be a side.
These 2 right here?
Yeah.
Can we assume that they're equal? Imagine the triangle wasn't split that way, right? Couldn't this slide around a little bit?
What?
Sure.
What is it?
Guys, the side that both triangles share is congruent for both. So check it out. We have side, angle, side. They share that side. We know they have to be the same because they share it. So side, angle, side is what we're rocking here. They share a side. That's a very common thing to look for. Look for shared sides and shared angles. So by side, angle, side, we know that these triangles are congruent.
Wait, so it's just SAS and not SAAS?
Where's the, no, it's not AAS. So they have a shared side, I'm sorry, they have matching sides, so that's the first S. Matching angle, so that's the first A. And then matching side, which is the last S. Okay? I won't write it like that anymore because it does look like it should be like SSAASS, right? But that ain't it. Number 2, you guys see the shared side?
Mm-hmm.
Okay, so they share this side right here. And we also have other sides, right? So we have side, side, side that's shared.
Triple S.
So that's triple S. Look at number 3. How can we prove those are congruent? We have matching angles, right? We have a matching side. These aren't right triangles, at least we don't know that they are, so we can't use ASS, right? We can't use Cheek's theorem, HL. So we should be looking for another angle. What angle do we know is congruent between the 2 triangles that wasn't given to us? Yep, these angles right here, right? Because these are vertical, right? So by vertical angles, we know those angles are congruent to each other, which means we have ASA. Are you smelling what I'm stepping in? Rad.
I'm a little.
Okay.
I'm not confused. I just don't know how, when we see them, how to know which ones mean they're equal. Like, I won't remember that.
Everything except for ASS and AAA is acceptable.
Okay.
Does that make sense? Right? And AAA, I remember, doesn't work because I can think of a 60-60-60 angle triangle, right? That's an equilateral. And then I can just think of a bigger one, right? It would still be 60-60-60. And then I know ASS doesn't work because it's funny, right? Which is why I do what I do. All right, so SAS for this one, again, seeing the share side was key. Again, the shared side was also key here for SSS, right? All three sides being the same. And then here we found vertical angles that got us that last angle to make ASA.
So do we just like go
So
and like
dumb.
kind of like order?
Yes, they do. The order does matter. It's ASA. See how the S is between the two A's? I can't go to this angle from here without crossing S, so it's ASA. Are you seeing it? Order does matter. Side, side, side. Side, angle, side. Because I can't get to this side from this side without crossing the angle first.
I guess the first one just confused me because you like
I wrote all the
of
A's and the
them.
S's. Yeah, exactly.
So like I've been writing all of them through every
Right.
single
For
one.
some people it helps, which is why I started with it, but for the rest of you, I would do what I did here and just write it for the one triangle, or even just mark them instead of writing S or A, okay? For number 4, what do you notice right away about number 4?
Wait, what was the
Looks like
number
a
three?
square.
Number 3 was ASA, right? ASA. Number 4 does look like a square, but we don't know that for sure, right? Squares have 90-degree angles. What do you notice about number 4?
Share a side.
They share a side. Boom. So we have an angle here and an angle here and a side in between, right? So we have angle, side, angle. So we have matching angles here and matching angles here with a side in between. Smell what I'm saying? You smell what's happening? Erica, how do you feel?
Better.
Better is good. Let's do 5. What do you notice about 5? They share a side. Again, this is one of the key things to look for, guys. So we have in this order angle,
See, like, how do you know that order?
angle,
Like, that was
side.
first?
Well, we can write it 2 ways.
It's on the other
We can
side.
either start at an angle, again, choose a starting point, right? Here's my starting point, angle, angle, side, or we can start here, side, angle, angle. The only place we can't start is here because we'd have to go both directions, right? So angle, angle, side, or side, angle, angle, both are valid, okay? Yes?
But what if you went from J to the side to M?
J
'Cause there's an angle
to
there
here
that
to M.
can't do.
Never mind.
So we focus on one triangle at a time. See what I'm saying? Yep, cool, alright. Again, this is where you guys should be asking questions. This is where it gets confusing. Yes, bless you. Alright, look at number 6. What do you notice? They share a side. That's the side they share. So just looking at the top triangle, we have a side that matches, then an angle that matches, then a side in that order. So it's what?
SAS.
SAS.
Yes.
Sorry. Number 7. What do you notice?
Same as 3.
It's basically the same as 3. This guy is going to be congruent to this guy by what theorem?
This isn't working.
Yes, please. There you go. By what theorem are these two angles congruent?
Oh.
Vertical angles, right? Scissors theorem. Seeing it now? Okay.
Wait.
That's
Oh yeah.
SAA works. AAS also works. Right? Either way, you can read it from the side going to the angles or the angles going to the side. You see if we go around the triangle, we hit angle, angle, side. Right? Or side, angle, angle without skipping anything, right? So I'm going to write angle, angle, side. What do you notice about 8? They share a side. Guys, are you getting the pattern here?
Yeah.
Sharing sides is really important. Okay? Shared sides are free sides. And everybody loves free sides, right? Apps and zerts. Right? Okay. So we have angle, side, and an angle in that order. ASA. Again, the only ones that don't work are AAA and ASS. Or SSA, if you go backwards, right? I think you can do the rest.
What about 11?
What about 11? What do you notice? What do you notice for 11? First of all, they share a side. Always mark that. That's going to help you. I missed mark.
Side angle.
Side angle is ASS. Side doesn't work.
Yeah. There's an angle there.
What about
Angle,
side
side,
angle
angle.
side?
What about? Yeah.
Side angle, but then we skip a side.
Yeah.
See what I'm saying?
Wait,
What if
but
you go from
the
the
side
middle?
they shared to K up to the one that's right
Side angle is what we have
No.
here. ASS.
What about?
up. Like
Side
start at
angle
the side and then go down to K the angle.
I think
and then
it's
go
Because
up.
it's a different triangle. Focus on one triangle at a
Well,
time.
Yeah,
go
that's
up to
helpful.
M.
Oh, that one.
We skip an angle, we skip a side.
No, go
Yeah,
from the
it's
share
impossible.
side to M.
Skip.
Side, angle, and then where are we going? We're skipping a side and an angle. Can't do that.
Can't do
Well, you're
it.
gonna skip something no matter what. So they must
Wait,
share
is it
another
nine like
angle.
that too?
Well, no. Wait, no.
Yeah.
9 is different because we have
Nine
side,
is
side, side.
Nine is side, so it's
Because they share the sides, right? So for number 11, how do you solve a problem like Maria? Can we prove them congruent? Can we not? Is there another way to go about this?
No, it's ASS.
It's
Wait,
ASS.
how come in 9 they can skip the angles?
So
because
for
it
9,
might be a right triangle.
so for 9, it could be a right triangle. We don't know that for sure. So Bailey, it's because we know all 3 sides because they share a side. So it's side, side, side. We don't have to worry about the angles there. So for number 11, impossible?
Yes.
Yes.
I think it's a defective problem.
So we're gonna say impossible with a question mark for now. We'll talk about this more tomorrow.
Do we do the backside?
Oh yes. Let's take a look at the back. Alright, so number 1 says FIG is congruent to what other triangle? So if you find FIG,
Big.
sorry, FIG on number 13,
Side,
sorry,
side.
is this one. It's congruent to what other triangle?
IGH.
IGH. Now, when we write these things, I am going to be a little particular about it because it's going to help you later in life, okay? So notice FIG is how they wrote it. That corresponds to HIG, right? And I know that because FIG ends in G, and this triangle has a G in it, so it should also end in G. So let me zoom out a little bit. So FIG, we're going to try and match up the letters as much as possible, okay? This is HIG. That way I can have all my letters match up.
Wait, so
Except
the
for H.
numbers that are on the bottom don't the numbers that are here?
Yes.
Oh wait, did we do the wait?
So notice that on 15, FIG is also congruent to HIG, right?
And so it's the back.
Yep. And this was by side, side, side. So for this week's quiz, we're going to be doing something very, very similar to this. We have an early dismissal tomorrow. We'll review Thursday, and then we'll take our first super easy quiz at the beginning. Do not bomb this first quiz. Yes.
I will be on the whack.
Yeah, me too.
That's whack, yo. What do you mean,
Breakfast
yo?
day.
Breakfast day? Yeah, bring in breakfast out here. I almost made apple cider cinnamon donuts this weekend.
You should have.
I should have.
You're
I'm
not
gonna
allowed to
cry.
eat them,
I love breakfast days.
Yeah.
Shelby, bring the chocolate
Yeah,
milk.
see, we don't have snacks club.
Still cups.
We have breakfast club.
You
Yeah,
bring the
that's
chocolate
not
milk.
Yeah.
I'll bring the cinnamon rolls.
There's gonna be a lot of people here.
I'm going to
Chair.
whack like
Chair.
next year, but
Is
I'm
that
not
your
going
meeting?
to whack
Yeah,
tomorrow
we'll
because
Okay.
that's donuts.
When is this?
That's a lot. Wait, this
Just
Friday?
get those
Complete
breakfast
this
ones.
for tomorrow.
That's not really out.
We're going to be doing basically this for our quiz.
Oh, my-
Yep, and the quiz is going to be super short. There's not a whole lot on there, right?
So don't, so if you mess up one, then you mess up like the entire essentially.
Yeah, right. Remember, since I do bonus points to make the quizzes smaller, even if I give you a 3-question quiz, missing one doesn't mean a 66%, right? That's how I make stuff like that fair. I want my quizzes small so they don't take a lot of time, but I also don't want them to be like, one question is the end all be all.
Yeah.
Homework?
Yes, it is. This is on you. I want you to go home and find questions like Bailey did with number 11, right? Find out where you get confused so we can talk about that tomorrow and Thursday, and then we can make sure you're good to go. Next week, what we're going to do is we're going to prove these theorems, right? The only one that's not a theorem is ASA. We have to assume one of them to be true to prove the rest. And I have chosen ASA as the one we will make a postulate in this class. Depending on which geometry you read, Euclid or Hilbert, they choose a different one, or they have a different set of axioms to make it work. We're going to choose ASA as ours. Everything else will be different. So we're going to prove side, side, side. We're going to prove side, angle, side, etc.
So what day are we doing breakfast day?
I don't know. I'm not in charge of that.
I'm gonna bring cinnamon rolls. Wait, Friday is our quiz.
Yep.
We should do it on Thursday.
You can do it Thursday while we study. Yeah. You have a question, Taylor? Yes? What's your question? Down your hand.
If you're gonna have to pay for something,
Don't even think about raising your hand in here.
something, even little.
Literally next week, I'm only gonna be here
What
3
sharp
days.
What?
Thing.